Alright, so in this video we're going to be talking about Newton's first law, and as with every other videos we will use a case study question to illustrate more about how we apply Newton's first law, because while it is something that seems very simple, it can be a little bit complicated, and we're going to break it down for this question and learn a little bit more about the law. As with every other videos, there are some general tips over here that you can take note when you're working on questions, and actually you can use some of these tips in the question that we will be working on soon. So take your time to read them, understand what they mean, and try them right now as we work on this question. So here you've got this question, which will be our case study for this video. Take your time to read the question. As I mentioned earlier, don't rush, make notes along the way, and see if you have any idea on how to work on this. And now we have the question, what we are supposed to do. Basically, we are supposed to draw the position of the object together with string for three cases: accelerating, constant speed, and slowing down. So at this point in time, you can pause the video to work on the question. You can also move the cursor back to the question itself to digest and start thinking about it. Grab a piece of paper, because that helps you to bring your thoughts up to the surface, and it brings you closer to getting the answer to the question. Try it out first. Doesn't matter if it's wrong, so long as you tried and you are familiar with your own thinking before you get engaged on the answer itself. And now we have the solution. And as you can see, object moved towards the left when the bus was accelerating. Object stays suspended vertically when the bus is traveling at constant speed, and the object moves towards the right when the bus is slowing down. If you are not convinced of the answer, you can actually take the bus or take the train. We have a lot of these handles that are suspended onto the metal bars, where people just grab them while standing on the train. Take a look at how they behave when the train is moving and when the train is slowing down, and this gives you a pretty good idea. Now, if you have gotten all three answers correct, congratulations. If you are very confident of your answer, that's great. If you are confused at this point in time, not to worry, the explanation to this solution will be coming up pretty soon. Alright, so let's look at the first diagram and why the object is moving towards the left. Now, we start off with Newton's first law, and that is the following. Make sure to remember the definition, because a lot of times that can be a 1-mark question. So during acceleration, what exactly is doing the acceleration? Basically, that's the bus. The source of the speed, the change in the speed, comes from the bus. The object itself is simply being pulled along by the bus, because the ceiling belongs to the bus, so the object is being pulled by the ceiling. As the bus increases in speed, the object, based on Newton's first law, will not want to change its current speed, which is 0, because the object was stationary at the beginning. So as a result, the object will be at a slower speed compared to the bus in that short moment. So at first, the bus is at a certain speed, the object is at a lower speed, and then as the bus increases in speed, the object takes on the speed that the bus previously had, and but because each moment the object will be at a lesser speed compared to the bus. So as a result, if you have an object that is at a faster speed, the object will be in front. So the bus will be slightly in front. The triangular object will be slightly behind because it's at a lower speed. As a result, you will see it swinging towards the left. Now, what happens when the bus is not accelerating? When the bus is at constant speed? This means that there is no change in speed in the bus. So as a result, the bus will be at a certain speed, but the object also will be at the same speed with the bus. So since the bus is moving to the right, the object will also move to the right at the same speed. As a result, it will simply remain vertical and not swing towards any direction at all. Now let's talk about the bus slowing down in the last diagram. Basically, you have the opposite happening as compared to when the bus is accelerating. In this case, the speed of the bus will be lesser than the speed of the object. The reason being is that the bus is the one, it's a source of speed and it is slowing down. The object, being reluctant to slow down, will therefore slow down at a slightly um, later time compared to that of the bus. So you have the ceiling at a lower speed and the object at a higher speed, and as a result, the object will swing towards the right. So I hope you have had fun looking at the question, the case study question, and you learned something today. If you have, that means I've done my job. You can challenge yourself further by trying out this question. Feel free to discuss it with your teacher, with your friends. Everyone's learning something, so that's a good thing. And if you have any questions, you have any comments, if you're unclear about some areas, you can email me at the following address, and I look forward to hearing from you. Alright, one more thing before the video ends. If you feel that you've gained a lot from the video, you've learned a lot about physics and you want to do more, and you want to really get the grade that you want. So I just want to let you know I do have tuition classes going on at Bishan and Clementi. Feel free to contact the center owners and they will let you know about the class fees and the availabilities. If you are looking for one-to-one, you can just contact me at the previous email address. Just let me know what you're looking for and we will follow up from there. So I'll see you in the next video. And in the meantime, have fun with physics.